All right, we are now in Unit 5, which is solving systems of equations. And the first lesson, lesson 5.1, our goal is I can solve a system of equations by graphing. So systems are two or more equations that have common variables. For example, y equals 2x plus 1, and maybe y equals 3x minus 5. There are two equations that have both x's and y's, or whatever the variables are. Notice these both have x's and y's, but the problem is there's two variables. So it kind of makes it a little tricky. It's a system, it's two together. So when solving a system, you're looking for a solution that makes each statement true. You're looking for a point in x and y coordinate, whatever that may be, that works in both of them at the same time. And I know that sounds a little weird. How can that happen? Well, when we're solving a system by graphing, how do you get the solution? Well, the idea is if there are two different lines, if it's going to be a solution, when you graph the lines, the only point that's on both of them or that solves both of them is the point where they intersect. So ideally what you're going to do is you're going to graph the lines and you're going to look for that point where they meet. And that's the one point that's a solution to the system that makes both of them true at the same time. So let's look at this example. Let's graph one in red. We'll do this first one here. The y-intercept is 2, so I'll go to 2 on the y-axis. Slope of 1, even though it's not there, there's a 1 in front. So we're going to go up 1 over 1. Okay, then let's graph the other one. Y equals negative 2x plus 5. So we're going to go to 5 on the y-axis. 1, 2, 3, 4, 5. Down 2 over 1. You can already see right there, right here, that point, it's the point 1, 3. That's a solution to the system. That being the case, we should check. If it is a solution to the system, it should make both true. So if that's my x and that's my y, is 3 equal to 1 plus 2? Yeah, 3 equals 3. And is 3 equal to negative 2 times 1 plus 5? Sure it is. All right, so you basically graph the two lines, find where they intersect, and that's a solution to the system. All right, let's look at this one. Now, if you remember from last chapter, section 4.5, you should recognize what's going to happen here. If the slopes are the same, we should have something interesting going on. So let's graph these. We go to negative 4, and we do a slope, excuse me, of 2/3 up 2 over 3. And we go to 5 and do a slope of up 2 over 3. And you see that the lines are, like you thought when I circled those, they're parallel. Okay, this is a special situation. If the lines are parallel, are they ever going to meet? No. So sometimes with a system, we can have that there's no solution to the system. And that's when the lines are parallel, and you'll recognize that when you see the slopes are the same. All right, let's look at another example. Now before we graph this, we have to solve for y. So I would need to divide everything here by 2, and that would give me y equals x minus 2. Notice, it turns out that this equation right here is actually just this one below it in disguise. They're the same line. So if that's the case, you're going down to 2 and a slope of 1, and you're going to graph the same line. I know it's kind of weird. How many solutions are there? Well, on any one line, there's an infinite number of solutions. Every single point on this line is a solution. So what's the solution to this system? Well, it can happen that it's actually the same line, that we say infinitely many. Or maybe they'll just say many. Okay, but it can happen that there's many solutions. I think there's an E here in infinitely. Okay, so what are the three possible solutions you can get when solving a system of equations? Well, you can have it where they both intersect, where you have one solution where the two lines intersect at one point. You can have no solution, and that's where the lines are parallel. Or you can have many solutions, where they're actually the same line. All right, let's practice one more example. If you have a piece of scratch paper, you can do this with me. Again, in order to do this one, we're going to have to solve. Well, let's do this one first in red. So we're going to go to 2 and do a slope of 1. The y-intercept is 2 and the slope is 1. And then we'll do the other one in green. We're going to have to solve that for y first. So we'll subtract 4x. Kind of just do that here. And we get 3y equals negative 4x minus 15. Divide by 3. So y equals negative 4/3 x minus 5. So let's go to negative 5 and down 4 over 3. Or up 4, 1, 2, 3, 4 over 3. And I believe this should have intersected. My line was off, but if I had done this properly, the point where they intersect is right here at negative 3, negative 1 is a solution to the system. Let's see if that works here. 4 times, oops, 4 times x, which is negative 3, plus 3 times y, which is negative 1, does that equal negative 15? So that's negative 12 plus negative 3. Does that equal negative 15? Yep, works in that one. Let's try it in the one below it. The y is negative 1. Is negative 1 equal to, the x is negative 3, negative 3 plus 2? Yep. Definitely wanted to make sure I checked that one since my red line was a little off. So it's good to use a ruler, and I like to keep doing like I did here, where you continue to graph the points so you can kind of see exactly where they meet. All right, how would you answer this question? Is the point negative 3, 1 a solution to the system? Okay, well, there's one of two ways you can do that, and this is going to come up on your quiz. You could either graph it and find where they intersect, or you can just test it like I was just doing. Test the point negative 3, 1 into each system and see if it works. So 2 times negative 3 minus 3 times 1. Does that equal negative 9? That's negative 6 minus 3. That equals negative 9. So it checks in the first one, but now I have to check it in the second one. Negative 3 plus 4 times positive 1. Does that equal 1? Well, negative 3 is actually positive 3. So does 3 plus 4 equal 1? No. So no, it's not a solution to the system. All right, so check, is it a solution to this one? Again, this is your x, this is your y. Is 1 equal to 3 times negative 3 plus 10? So is 1 equal to negative 9 plus 10? Sure it is. Okay, and then now let's check it in the other one. Is negative 2 times negative 3 plus 7 times 1, does that equal 13? So 6 plus 7, does that equal 13? Yes, it does. So to check to see if the point's a solution, you need to put it back in and see if it makes them both true. All right. So the wrap up, list and give examples of 3 possible solutions to a system of equations. So you could have one solution, you could have no solution when they're parallel lines, or you could have where it's the same line and it's many. All right, that's section 5.1, how to solve a system of equations by graphing. So go ahead on to Apex, and you can do section 5.1.3. If you have any questions, again, come see me. I can show you some more examples or give you some more notes if needed. Thank you.